Hi everyone, welcome to lesson 8 and the first lesson of part 3. We're going to talk here about applied nutrition for reproduction. And I think you're going to like how this works because it's going to be a review of everything we covered in part 2, only all mixed together as it applies to the pregnancy and lactation periods. As always, we're going to start by talking about our nutrient needs. And we're going to start by talking about those that are biological and also the psychosocial influences that drive our nutrient intake. First, biological nutrient needs. And a quick distinguishment is that these are the ones that are determined based on the levels of nutrients in the body. They are typically neurohormonally signaled so that we feel the need to consume foods that contain nutrients. When we talk about the nutrient groups that support reproductions or the classifications, we're looking at both those that support the phases of fetal and maternal growth. And this pregnancy phase lasts about 40 weeks that are broken into 3 trimesters. These nutrients, there are many of them, most nutrients. In fact, pregnant women need more. So we won't talk about each of them individually, but they need anywhere from 10 to 50% more of each of these nutrients per day. The second phase or the second functional nutrient group is to support breast milk production. And these are not only the nutrients that are in the milk itself, but the ones that it costs mom to produce, which is actually even higher than most of the increases that we see in pregnancy. So for many of those nutrients, not only is it higher than the non-lactating woman, but it's also even 5 to 25% higher than pregnant people. So it is important to have healthy nutrition during the lactation phase, especially if you're going to be breastfeeding for an extended period of time, such as the longer and the 12-month postpartum period. And some people even longer. And just on a personal note, I breastfed for a way longer period than that because it was convenient and I knew it was healthy. And frankly, it was free and all of those things that are great. But a lot of women don't, and for understandable reasons. If you added up all of the nutrients in a day, you would be looking at, during both periods, each day, that would equate to about 75 to 100 extra grams that were needed to be consumed. And for perspective, that's about the size of a standard bar of soap, or about 3 to 3.5 ounces. Oops. So the nutrient intake guidelines, we're pulling those from the DRI, or the Dietary Reference Intake. Same thing we did in part 2, except that this time we're only looking at the RDA, which satisfies most of the female needs of pregnancy and lactation. And these are based on experimental studies, which we'll look at next. And then the adequate intake value. And I don't want to call these lower quality, but they're not as valid and as reliable in terms of precision for values. For example, they're based on reference medians, and these are observed values looking at maybe survey intake and then looking at healthy pregnancy outcomes. How much weight did she gain? How much did the baby weigh? And all of those kind of things. So these are the standards or the medians that the DRI are based on. And again, not that you need to memorize this verbatim. It's just to help you understand the difference between these two when you see them marked for each of the times that we discuss the nutrient intake guidelines. And then more importantly, when we talk about how milk output costs so much, now you'll know based on what. It's based on a 0.78 liter per day output. Median, I should say that again, like an average, the median, what the average pregnant person did. So in experimental research, again, these are the good ones. This is where we're getting our RDA values. Those are based on just healthy people balance studies, the same thing they did for adults. But in this case, after we feed them out and get the intake and then measure and collect all the losses, like from urine and feces and sweat, and in this case, menstrual losses. And then if we look at the amount retained, instead of it just being for our tissue maintenance, like as we're turning over tissues, at least in the adult phases, we're also looking at new tissue deposition and maintenance. So those tissues not only have to be laid down, groundwork, anabolism, but also those tissues have to be maintained, right? So higher metabolic and metabolic rate, all those things. Now, these new tissues are both fetal and maternal. And the fetal tissues, we're talking about the fetus and the placental tissues around it. And then maternal tissues, things like the uterus and the breast and any extra fat that is acquired. And then during the lactation phase, the retained nutrients should be balanced. That's why they're called balanced studies, with exactly how much milk is being produced and the composition of it. So I know that that's a lot of detail and probably more than you would need. And you can fast forward. I probably too late for that, but I'm not going to like detail you and grill you on those kind of things on the test. It's just to give you an idea of how we establish, how do we know that they needed this much more, many more milligrams of this nutrient each day. And then this is where the professional experts come involved, because the observation studies are based on things like at hospitals and at clinics, OBGYN clinics, like what is the average weight gain per trimester, what kind of food and what nutrients are they consuming, and how healthy was the baby, what was the baby's birth weight, how long was the pregnancy. So these are where, if we go back, where the professional collaborates with all of the scientific studies done in research. So those case studies, all of it comes together, and that's how we know about how much they need. Starting with the easy stuff, no change in these nutrients from the pregnant to non-pregnant state, or I should say non-pregnant to pregnant state, except in the case of young pregnancies, 14 to 18-year-old adolescents need more because their bones are still laying down mineral tissue as well, and they still need those added amounts. And that's a significant jump. 1,300 to 1,250. That's a lot. It's a big jump. Otherwise, for everyone else that is above the age of 19 to 51, there is no more reason to take any more of those nutrients. We do not keep them. And we will talk more about that in component 3 when we talk about skeletal mass and the importance of mom's bone mass in fetal development. However, I would like on that note to say these are all very important nutrients. It's just that you don't need more to sustain a healthy pregnancy. Also, no change in lactation for these, except for vitamin D in the case of no sunshine, because you have to have the vitamin D in the breast milk, and not a lot of diet sources. There's a review of what we've spoken of already. Fortified vitamin D milk is about the best one, but other than that, we get most of our vitamin D from the sun. So in regions or personal preferences where there's not a lot of sunlight taken in, an OBGYN or even a doctor might recommend that you supplement vitamin D at postpartum, just to make sure. So macronutrients for pregnancy, lots and lots of points on this slide. I'm going to try to keep it concise. Notice there's no energy differences in trimester 1. So all those extra fun things that we eat, I feel like that was my hungriest period during those first couple months, but there aren't technically any additional energy expenditures. Now during the second trimester, energy expenditure increases by 340, adding it to just the regular healthy adult EER, as you learned in lesson 1, to get the pregnant RDA, which is just the EER plus 340. That's very straightforward. You can see here that it jumps up a little bit, the added daily pregnancy need, which is what this column is. And that's to sustain the fetus moving, because during this third trimester period, baby's moving, that costs an additional 112 calories, and that's added to the EER. When it comes to protein, lots and lots of balanced studies on protein. Protein was an important nutrient to square away. Protein needs 25 extra grams per day to lay down a healthy baby and all the tissues that are needed. And so because of that, the RDA jumps up from 0.8 grams per kilograms per day to 1.3. So that is quite a significant jump during the pregnancy period. So average body weight of, or not average, I have to say that again, median body weight of pregnant person times 1.3 grams of protein per kilogram, 74 grams, and boom, there you go, 71. And it is a little low, but remember, RDAs meet 97% of the population's need because they round way up from the more precise value of the EAR, which I promised we're not discussing. Let's see, what else is on this slide? Fiber increases, but just as a function of calorie intake. Notice it's an adequate intake value. Just because calories go up, so do the grams of fibers, because it's a proportional value. Same here with linolenic acid, which is otherwise known as omega-3. These also go up, as you can see, but sometimes some people aren't great at in the body converting those to DHA and EPA, which are, again, those long-chain fatty acids that you learned about in lesson 3, and those preformed fats. Some experts suggest getting some of those stand out alone. So in other words, instead of consuming all of this as omega-3, reaching to get most of it, in fact, look at 1 to 2 parts of it out of the 3 milligrams, trying to get most of it as preformed DHA and EPA. When it comes to micronutrient needs for pregnancy, really 3 sets of nutrients are important. 1, iron. And iron is important because mom's blood volume is expanding like crazy. And to be able to adequately deliver oxygen, mom needs to produce more hemoglobin to make sure that the distribution between the volume of blood and hemoglobin is right. For that, moms need lots of extra iron. And in fact, so much extra is needed per day that the increase is 60% greater than during the non-pregnant state. And not that you would need to know all of this, but a couple important things, because if you're looking at the math and you're like, well, if maternally needed 18 and then the pregnancy needs 22 milligrams per day, then how does it only add up to 27? And there are 2 factors at play here of why this math doesn't add up. Number 1, bioavailability of iron increases by a lot during pregnancy. So instead of having an absorption efficiency of 18 to 20%, we're looking more in the zone of 25 to 30%. So meaning that if we eat, let's say 10 milligrams of iron, during pregnancy, we're going to absorb almost 3 milligrams of that compared to potentially less than 2. So we're absorbing better during pregnancy and the cessation of menstrual losses. So now this accounted, and this is so much higher than the male RDA because it accounts for the amount of iron that is lost every month in menstruation. So without that during pregnancy, and then again accounting for the higher bioavailability, even though the need for baby depositing iron is astronomical, the need for hemoglobin expansion is astronomical, the daily increase isn't that much. It goes from 18 to 27. Let's see, folate is another important one, and it didn't have any fancy math, so I didn't need to really show anything there, but folate increases by about 50%. And if you look at any prenatal supplement vitamin, they'll always contain anywhere between 400 and 600, just to make sure that pregnant women, especially during that first trimester, are getting enough folate. And we'll talk in component 4 about the functions of these nutrients. I already gave a little away with iron and hemoglobin, but folate is critical during that first trimester for neural tube development. And again, we'll talk more about that in functions. You can see that iron and zinc needs go up. This is basically just babies building. Lots of minerals are needed. These are your energy nutrients. And so because it takes a lot more energy to build tissues, we see these energy pathway nutrients increase by about anywhere between 20 and 30%. Just so you guys know, it already says here, but these are listed in order by percent increase from the non-pregnant condition. Now, during lactation, we're looking at macronutrient needs, and you can see that calories, it's kind of determined similar to pregnancy, where it's the regular EER plus the amount that's needed for milk. And this includes both the milk energy itself and the amount that it takes to produce it. And what you can see is the EER plus the 500. And then if you're like, well, what is this minus 170? The minus 170 accounts for everybody is going to come out of pregnancy with 15 to 25 to 35. I actually had 50 extra pounds to lose of deposited fat. So that is actually taken out of the equation so that maternal body weight, what did I do there? So that maternal body weight can be restored. Now you'll notice that during the second phase of lactation, during the 7 to 12 month period, breast milk production slows as baby starts to eat compensatory foods, milk output is reduced, and therefore it is only plus 400 calories in addition to the regular daily maintenance needs. Notice also that the mobilization of fat tissue is gone because by 7 months postpartum, all of the maternal fat stores should be gone. Protein, it's exactly the same as during the pregnancy phase. To keep it simple, it's bumped up from 0.8 grams per kilogram body weight to 1.3 grams per kilogram body weight. Same thing we covered on the macronutrient slide for pregnancy. Now, water we haven't talked about yet, but we can intuitively understand why water would be such a critical nutrient for lactation. In fact, water, and it happens naturally, our beautiful neurohormonal systems ensure that we get that extra water by sending signals of thirst and waking us up in the middle of the night to take drinks of water. But this is a 1 liter per day estimate for about how much goes into milk. And if you're looking back at our standards, which excuse my flashback here, but you can see that the standards are right here. So it's a little less than a liter. It's 0.78 of a liter today, 0.7 liters. But once you add in the cost to produce the milk, they went ahead and just rounded it up to 3.8 liters per day. Micronutrients for lactation. Now, this is interesting. There's lots, obviously the needs are much higher for, 20 something to 30 nutrients. I only listed the ones here that are higher for lactation than pregnancy, because basically we're already eating a certain way for almost 10 months. So I only included the ones that jump up again during the postpartum period. Now, notice iron, folate, and niacin go down compared to pregnancy, but several nutrients go up, most notably the antioxidant vitamins A, C, and E. But interestingly, they're not really valued here for their antioxidant qualities. Vitamin A is actually important for gene expression and for tissue differentiation as the fetus grows. I'm sorry, not fetus, the newborn grows. Vitamin C is super important for collagen synthesis. And remember, like we talked about in the vitamin lecture, very important for cross-linking and developing skin and new connective tissues. And vitamin E is integrated into every cell membrane. So as cells are multiplying and babies growing very rapidly, vitamin E is needed to be integrated into cell membranes because that is, again, our cell level antioxidant. It's a solid one. It doesn't come in and out like vitamin C. And what else? Lactation. Vitamin B12. This is an important one. The jump isn't humongous. I think, maybe it's 20% higher per day, but it's such an important nutrient because the breast milk has to have B12 for baby to be able to grow and divide cells appropriately. So vitamin B12 intake during the lactation phase is important. Even though the jump or the need isn't much higher, inadequate intake is not good. So, lactating women who are following vegan or really strict plant diets want to make sure that they're getting enough B12 from either, plant sources or from supplemental sources. And a lot of way to remedy a lot of this is that OBGYN suggests staying on your prenatal vitamin during the postpartum and lactation phase. Now, the funner part, and obviously much less technical and simple, are our behavioral nutrient needs. And these are the ones that are not driven by the body's nutrient levels or actual biological needs, but they're driven by the psychosocial things that drive our food intake. So we're talking here about those psychosocial factors that affect nutrient intake. And in this case, these are the things that are inside us, the internal controls that control our diet. And these are based on just who we are, our intrapersonal needs, our preferences and habits, and just what makes us up as a person. And in the case of pregnancy and lactation, there are lots of things associated with cravings and having just a different appetite than usual. There's customs, like as in the United States and in a lot of developed places, there's prenatal care, which includes supplementation, all kinds of different standards for when baby's born, values like as being a vegan or vegetarian during pregnancy. Of course, people's goals are something that absolutely affects their dietary intake, and goals can include things like having a healthy baby, having a full-term pregnancy, restoring pre-pregnancy weight, which can, making sure that you're controlling the gestational weight gain. And then obviously, same as always, the nutrition information literacy piece, which is essentially if you know how to look at a food package and read those features, like with DHA, and you know how to tie those to the benefits, and usually they'll tie them for you right there on the package, but like such as a healthy baby or healthy membranes or healthy eyesight, whatever they're going to tie it to, if you can read those features and benefits on those food packages, that's also going to influence dietary intake. There's also external controls, and these are those like more social things. When we talk about psychosocial, these are the social aspects of psychosocial, and these are the external things in our environment. Things like socioeconomic limitations, that absolutely affects nutrient intake, and especially for pregnant females. And there are food assistance programs, at least here in the United States, to support pregnant women and lactating women. It's called Women's Infants and Children, where they'll go and take classes and for learning about nutrition and healthy ways to breastfeed and healthy ways to feed your children and yourself during pregnancy, they'll give you free food vouchers. I've actually taught classes at WIC and I found it incredibly rewarding. There's also nutrition promotion that affects our nutrient intake. I won't go through all of these, just kind of showing you the alignment between the United States goals or healthy people. These are the goals for 2030 related to pregnancy and lactation, and the World Health Organization. Many of them align, and you can see they're related to low birth weight, less gestational anemia during pregnancy and during the reproductive age in general, and including the proportion of the population that breastfeeds. That's another important initiative. Breast milk, and especially in places where formula isn't readily available, it's free and it's healthy. And if you can produce it and it isn't uncomfortable, and it really is the best thing for the baby, which we'll talk about more in lesson 9 with nutrition for the ages. These are just more examples of promotions for breastfeeding. It really is highly encouraged and promoted in most arenas. When it comes to nutrition marketing, there's actually only one FDA approved claim related to pregnancy, and it's for folate and neural tube defects, none related to the lactation phase. However, there are tons of unsubstantiated claims on supplement products on the market, things like food grown pregnancy, and this is indicating that, none of the small little teeny particulates that are used as ingredients in this supplement were made synthetically. They were all natural food sources. Also, you'll see claims like relieving nausea and constipation, and we'll talk a little bit more about that in part 3 about how those are sometimes caused by pregnancy, but these are the types of claims that supplements are making. You can also see here things like natural. Again, that kind of goes with the food grown. When you're pregnant, you don't want to think about putting chemicals in your body, even if those chemicals are synthetic nutrients, which for the most part match or are superior to the ones in food. But what is not superior, P.S., to the ones in food is the whole array of nutrients that come in the food package, but in the case of single nutrients at a time, like folate, supplementing is the best because you absolutely have to ensure you have it, and then you go on the food matrix path for getting a nice balance of all the nutrients. There are also supplements that are marketed to lactating women, such as galactagogues, which is a compound that is also consumed in the diet, but usually isolated and used in supplements, that supposedly increases breast milk production. There's tons of good anecdotal evidence on this from pregnant women who say it helped, but the research kind of goes both ways in terms of the dietary supplement compounds making women produce more milk. There are prescription level galactagogues, though, that do work. Now we're moving on to component 2, looking at those sources of nutrients in our diet. We're going to talk here about the whole and the processed foods and the nutrients they provide in closing that gap between the non-pregnant and pregnant woman's nutrient needs. First, we're going to talk about whole plant and animal foods. So first, we're going to look at fruits and vegetables, our first whole plant group. And you can see here from the column far left, this is the added daily pregnancy need for each of these nutrients. And then you can see here, each of these servings of fruits and vegetables provides the amount provided in these cells. All of the green cells, and I'm only going over this so slowly because it's going to be the case for the next several slides. The green shaded cells are providing 100% of that extra daily need, and the light pale yellow cells are at least 30%, okay? So you can see where the powerhouse potential of fruits and vegetables are coming in play with providing lots and lots of fiber and providing lots and lots of vitamin C. Also, several provide the vitamin A that we're looking for during the lactation phases. Nuts and legumes, following that same principle, you can see that they're great sources of fiber in general. Looks like they're also providing folate in some pretty significant amounts. And folate is, again, one of those critical nutrients during the first trimester. And their powerhouse or their superpower in the reproduction phases are the magnesium levels. All 3 of these types of nuts and legumes satisfy 100% of those additional magnesium needs. What you can see too is that these foods, although they're a great source of magnesium, not a very great source of iron. Now we're looking at nutrients in whole animal foods. And when you're selecting animal foods or meats and eggs and milk and thing of that nature, you're making sure that you're looking for low in additives like nitrates that are often in cured meats like lunch meat, and also minimizing contaminants such as mercury in fresh fish and bacteria, which there's many kinds of bacteria, and we don't really need to spend a ton of time going through time and temperature abuse things, but we really care a lot in the pregnancy phase about making sure that the food that we're consuming is safe. And for that reason, that's why sushi is not recommended. Undercooked eggs are not recommended. These are oftentimes are common harbors of bacteria that make us ill. Same with unpasteurized milk and soft cheese, because these soft cheeses and unpasteurized milks contains specifically a bacteria called Listeria that's extra dangerous. And in the case of leftovers and warm foods, I'm not going to say that they're not something that is not advised for pregnant and lactating women. It's just that it isn't a good idea unless you're handling them properly. So if you bring something home from a kind of sketchy restaurant, you want to make sure that you're heating it thoroughly and taking care of your leftovers and, making sure that it's refrigerated. When it comes to meat and milk, you can see the powerhouse here is protein, magnesium, not surprising, zinc. And in the case of iron, only beef is providing a significant amount. And now you should be kind of scratching your head about, gosh, well, where are we going to get all that extra iron every day? And that's a little bit of a foreshadowing to, that's why we take some of those prenatal supplements. Let's see what else here. B12, this is 100%. All three of these animal sources provide an adequate amount of B12 in the diet, which is very important. And then the fortified milk is fortified with vitamin A. So that's also providing a significant, actually all of the amount that's needed extra to support pregnancy and lactation. When it comes to the nutrients in processed and formulated foods for reproduction, let's hone in on some specific compounds that are provided. For functional additives, sometimes people are advised to buy wheat germ, which you can sprinkle on oats or cereal. You can also use it in recipes, but some of the nutrients are destroyed. But wheat germ, which is the little component in one wheat kernel, provides a good source of folate and vitamin E. Also, sometimes women take fish oil, but it's very important that fish oil, it doesn't have a lot of added vitamin A, such as like a cod liver oil, because you want to make sure we don't lump too much vitamin A in pregnancy. And we'll talk more about that in a couple minutes. But sometimes people do take DHA and EPA or preformed essential fatty acid supplements, as long as they don't have a lot of vitamin A, such as cod liver oil. Phytonutrients that are sometimes taken during the reproductive phases include ginger for nauseousness, peppermint for nauseousness, or fenugreek, like I mentioned before, which provides a compound called galactagogue. In the bottled beverages category, really healthy things are orange juice that are fortified with calcium and vitamin D, because they really also provide a great source of vitamin C and potassium naturally. So together, a good glass of orange juice is kind of a powerhouse for getting a lot of these extra nutrients. During the reproductive phases, both pregnancy and lactation, we're very much limiting or excluding caffeine-containing beverages and very much excluding alcohol. Anything in a wine, beer, or spirit could be harmful to the fetus. And it is not a great healthy thing to do during lactation either. Some people swear by the fact that hops might stimulate lactation, just like fenugreek. It is not true, but it is also not a big deal to have a single beer or a single cocktail during lactation, but you want to just make sure that you're doing it very modestly and in coordination with maybe supplementing with something that you have in the freezer or even a formula if you're going to choose to do so. When it comes to processed grains, I cannot say enough good things about your ready-to-eat fortified breakfast cereals. Just a single 1 cup serving provides a significant source for all of these listed nutrients, satisfying at least a third and usually more for all of these, and satisfying 100% of your daily need for thiamine. I couldn't recommend a bowl of cereal more. I lived on cereal. Oh my gosh. And again, a lifetime of high sugar cereals aren't a great idea, but during the reproductive phases, even a little bit of a sugary cereal as long as you're not developing any signs of pregestational diabetes or showing any signs of difficulty controlling blood sugar, 1,000% recommend cereal, even if it comes with a little bit of extra added sugar. But making sure we're focusing on, if we are snacking on grain foods, that they're whole grain. I do notice during pregnancy, women like to go with portable snacks, whether they're little granola bars or crackers, things that sometimes help subside nausea, which we'll talk about in the functions of these nutrients in component 4. Dietary supplements are also very common, and these are prescribed usually by OBGYNs, and sometimes sometimes females choose to purchase their own over-the-counter varieties. You'll notice that the pregnancy RDA, this is again the amount needed per day for pregnant women, is usually they aim to satisfy, more, at least or more than the pregnancy RDA. So these are common doses in your typical run-of-the-mill supplements. I think I might have actually even chosen a prescription type prenatal vitamin, but either way, they're in this zone of what they provide. You'll also notice when we talk about ingredient forms that they'll use the most bioavailable form possible. If you're looking at higher ends, like methylated folate, which is, it's already been converted and methylated in the body. So that's a very absorbable form and highly bioavailable. Something also very important to notice is vitamin C, is making sure that we're not getting too much vitamin C, but just enough. Also, beta carotene, another one that you're going to see in supplements, but you want to make sure if there's vitamin A in the supplement that it's beta carotene. Because remember, vitamin A accumulates and we don't want excess vitamin A. We want to make sure that it's beta carotene so that our body will convert what we need to beta carotene. This is just an example of a supplement that's in a drinkable form. And I love always, promoting food products, not really promoting actually, kind of more of anything, kind of talking smack about them. But this is promoting healthy hydration for not only pregnancy, but also labor and also breastfeeding. So they're taking in the whole market and saying that they're providing hydration, electrolytes, plus vitamins and folic acid. Folic acid is a vitamin. That's where I love to get these kind of things. By the way, it says low calorie and sugar free. I have no idea why I'm looking at this now, but I'm 99% positive this is what came. Yeah, Aqua Mama, 19.5 ounce. Looks to me like there's more sugar than not. So, okay. Yeah, I definitely caught myself and I can't stop this again because it's taking too long, but yeah, go think on this one for a second. Look this up and see if you can find the list and see why they say that it's low sugar, but it has 12.5 grams of sugar. So when it comes to confections and desserts, there is no quandary that a pregnant woman loves her ice cream. I mean, we've all seen the jokes. So yeah, it's kind of true though. You get those nighttime cravings and you're also kind of thirsty, obviously. So it just does all these wonderful, cold, satisfying things. But also there are ice creams that have digestive enzymes for people who are lactose resistant. So these enzymes are added, or lactase enzymes are added to help them be digestible. This is a particular brand that's marketed specifically to pregnant and lactating women. It's from the American Pregnancy Association. But I just put this up here because I thought it was kind of funny that it reinforced those external eating cues, those things that drive nutrient intake outside of biology. Look, night food. I mean, they're saying like they're normalizing this. And by the way, again, I had 3 pregnancies and I did this every time. So it's pretty typical. It's just funny that these are the things that are reinforcing those behaviors to us instead of, us trying to control those behaviors. Meals and recipes. I'm just going to leave you to have that on your slide, just to give you a good breakfast idea for overnight oats, but lots and lots of nutrients and mostly iron, protein, and folate. Now we're going to talk in component 3 about nutrient processing. And in this part, we're going to talk about the digestion changes, the metabolic changes, and the circulatory changes during the pregnancy and lactation phases. First, digestion and absorption. In pregnancy, there's a gigantic amount of increased pressure in the gastrointestinal tract. even from the very get-go, it feels like you're bloated from day one because all of those extra tissues being built in that area is directing a lot of blood flow. And then, of course, as baby grows, it puts a ton of pressure on those intestines. And there are also hormonal changes that cause a relaxation in the smooth muscle in that endothelial lining, and that causes pregnant women to be at an increased risk for nauseousness and vomiting. In the mouth, we have increased microbiota, lots actually extra. In fact, just to foreshadow ahead, there's increased microbiota through the entire gastrointestinal tract, just preparing us to have a strong immune system throughout. There's also increased salivary acidity, very interestingly, helps us break down that food a little bit better, prep it a little bit better for absorption. Because of that acidity, though, we also see an increased risk of tooth decay. In the stomach, you're going to see a big time relaxation of that pyloric sphincter. It relaxes because that's what the hormones are telling every squeeze tissue in our body to do, including connective tissues and muscles. They're all so relaxed to create that laxity we need to spread out and create room. That happens also in the stomach, and that little flap that covers our esophagus is loosened and weakened. And so pregnant women are also at risk for reflux. And not only because of that, but the increased pressure from the baby pushes on that flap upwards also. Also in the stomach, if you remember back from the vitamin lecture, vitamin B12 is only absorbed by a compound, a little protein that is secreted by the stomach called intrinsic factor. And intrinsic factor secretion during pregnancy increases, as do the secretion of gastric juices. So again, more acidity, better breakdown of those nutrients, making them more absorbable. In the lower gastrointestinal system and in the small intestine specifically, in the brush border, there's what's called increased paracellular absorption. And I'm sure I've already mentioned this term in several other lessons in part 2, but that means when the nutrients go, and I'm going to have to do this a few times because I love animations like this, and I don't do them a lot because they're often uncoordinated with voice issues. But see, when the nutrients don't go through the enterocytes, but they go between them, that's called paracellular absorption. And that is increased during pregnancy. Also, within the enterocyte, if you guys remember from lesson 6, when we talked about minerals, calcium can only be absorbed through this membrane, which doesn't matter as much as calbindin, which is something that it needs to bind to. And also, if you remember, vitamin D activates calbindin. That's why we need vitamin D so much. And some of the regulation of calcium is because without vitamin D, there is no calbindin. And without calbindin, you don't bring calcium into the blood. Now, during pregnancy, the expression or the making by genes of calbindin is increased significantly. So we have a greater absorption of calcium during the pregnancy and lactation phases. Oh, I forgot about that one. That's absorption of calcium by calbindin. In the large intestine, we have a better concentration of feces. So we are increasing more water because remember, mom's blood volume is going bananas, which is the very next topic. But blood volume is increasing, and that puts her at risk of constipation, and that puts her at risk of hemorrhoids. So one of those downsides of being pregnant is that you need more of that water that you're secreting during the gastro process and that you're consuming in drinks. And because of that, your stool is harder. Also, like I mentioned, in the mouth, in the mucosal lining, lots more intestinal flora, both the diversity of the microbes that are there and the count. And they have lots of different protective effects, but mostly to just keep our immune system healthy and keep us protected. There's also, though, with the increased microbes, However, with increased number of microbes come increased the metabolism of microbes, come increased their gas production, come increased flatulence. And so that's also a downside of being pregnant. And it isn't just the extra pressure, which is contributing in the third trimester, but even at the beginning where those microbial counts are increasing, obviously they're producing more gases. We're producing more gases with flatulence. Now moving on from digestion and absorption to the way that nutrients are circulated and delivered in the blood. So first thing that happens during pregnancy, which is awesome and kind of a little foreshadowing on metabolism, is that in the endothelium, which is the lining in the blood vessels, those have a particular hormone called atrial natriuretic peptide that increases the production of that. In the endothelium, there's an increased production of a particular peptide. I won't say it, but it's right here. I would never test you on that. But this increased production of this peptide increases the ability to vasodilate. So that's one of the great adjustments during pregnancy. Also in this endothelium, and specifically in the cells of the endothelium or the endothelial cells, there's an increased production of a hormone called lipoprotein lipase. And lipoprotein lipase, it's produced right here in this lining. It squirts into the blood and it helps break down the cholesterol and fatty acids in these chylomicrons right here. Actually, sorry, that's not a chylomicron. That's probably, let's call this an LDL. It could technically be a VLDL, but this is cholesterol. It takes the fatty acids inside, LPL. It breaks that fatty acid and then it's able to be absorbed into, let's say, a fat cell for storage later. So while we're pregnant, we really care about vasodilation, getting blood everywhere it needs to go. We also care a lot about making sure that we can store enough fat. And that's why lipoprotein lipase production activity increases, is to support the cleavaging or the breaking of those fatty acids. In the blood volume increases by 1.5 liters, which if a healthy average adult includes about 5 liters, you can see that that's a lot. Blood volume is expanding by 20, let's even say closer to 30%. And with that, those other things that are proportional to blood need to increase also. So we need to produce more white blood cells, which is more protein demanding. And we definitely need to produce more red blood cells, which we'll talk about again in component 4, but which is iron demanding. Now, even though the body works very hard to produce more red blood cells, we still see a net reduction in hemoglobin. So even though there's more red blood cells, the total packed volume of those red blood cells is still lower relative to the expansion of the total blood volume. Now, in the postpartum phase, very interestingly, 2 to 3 weeks it takes to restore that blood volume. So it comes really quick in pregnancy within weeks, and then it also leaves very quickly after that baby is out. We love that extra blood because it carries extra nutrients. It supports baby in every other extra way. We need a lot of it. And blood cell counts are also restored, but they take a little bit longer. And blood cell counts also decrease, again, just proportionate to the increase in total blood volume, but they are restored in 4 to 6 months postpartum. Now, during pregnancy and lactation, oh my gosh, if I had to say there was one like rock your body world phase, it would be when it comes to nutrient responses, and specifically looking at the endocrine system. Holy pregnancy mark the endocrine period. Pregnancy and lactation are the most hormonal periods ever, which is why you'll hear jokes about the pregnant woman's hormones, brains, emotions, because it is the most surging period for hormones to be produced. First of all, the placenta is producing hormones. The pancreas is getting bigger, and the cells of the pancreas are getting larger and increasing their volume to produce more insulin. There's way more insulin being produced. There's way more HCG, which is human, I'm not even going to say it, HCG. There's also lots of placental lactation during the lactation phase, and there's increased just regular sex hormones, estrogen and progesterone. So it is a hormone surge, and those hormones dictate all of the different phases from the time it happens from when it's time to go into labor. Now, when it comes to regulating the water supply in the body, very sensitive changes during pregnancy. And these are exactly the things we already covered in lesson 7 with water. So I won't go over it a ton here, but when the second you get pregnant, to make sure that we can absorb enough. One significant hormonal change during pregnancy is our increased sensitivity to sodium. So we quicker detect sodium imbalances or deficiencies. And then because we need that sodium to retain more water. So because of that, our pituitary is more hyperactive about releasing ADH. And because of that, we release more adrenal hormones, including renin and aldosterone, which are two hormones that make us keep more water or reabsorb more water through the kidneys. So just to reiterate there, we have endocrine changes during pregnancy, one big expansion in blood volume. One of the ways that that happens is that we become more sensitive to low sodium levels so that we secrete hormones that ensure we keep it at the kidney filtration level. We also see a change in the way that we signal and sense calcium. So calcium levels in the blood are very tightly maintained. In fact, within a window of like 1%. So the thyroid regulates this. The second it sees that calcium might be somewhat deficient, it releases parathyroid hormone, which tells the kidney to activate calcitriol, which is the active form of vitamin D. And calcitriol is like the trifecta of keeping our calcium in our body. So the response happens in 3 separate areas. That's why I said trifecta. Get it? That's a horse race joke. But if you're talking about in the kidneys, we see that there's a greater reabsorption of a greater reabsorption of calcium. If we're looking at the bone, we're seeing greater resorption. Instead of letting go of calcium, we're keeping more in the bone. And also calcitriol makes sure that we absorb more. And I wish we were in a live setting because I would say, through what compound? You guys would say calbindin, because that's right. When calcitriol is activated, or the active form of D3, it goes down there and activates calcitriol to absorb more calcium. In the bone, it stops osteoclasts from breaking it down. And in the kidney, it stops it from being secreted out in the pee. So that is one of the hormonal or endocrine responses during pregnancy, and the way that we maintain all of our bone mass, even though the baby needs that calcium too. Which, by the way, I think I say this later, but if not, I'll say it now. We give up a good amount of skeletal mass to have a baby. So since you've been born, you should thank whoever you came out of, because she sacrificed bone mineral density for you. Now, one more hormonal response is during the lactation phase. I know we focus so much on pregnancy, but really that is where a lot of the research on a lot of those hormonal adjustments exist. But a very awesome one during the lactation phase is that even response to the baby crying, obviously suckling makes sense, like sucking is going to generate something, but even crying releases a hormone called prolactin and oxytocin. And those two hormones together cause breast milk production, and they cause breast milk ejection or release at the tissue. And this is why even without the baby being latched on, the breast can start releasing milk, because those levels of oxytocin. Now, during the pregnancy phase, we can see that there's a huge increase in insulin sensitivity so that our cells can take up more sugar. We also see an increase in GLUT4 transporters for the same reason. Yep, more nutrients exchanged, more transporters, more insulin. The metabolic changes, as you could probably assume, are anabolic. They're building. In the liver, we're making more fats for storage. We're making more cholesterol. These are typically things we don't want. And I think we've emphasized in part 2 and lesson 3 with fats, but in this case, we love it. And I think we'll talk in lesson 10 about why we don't love it. But here we do. We need that extra fat storage and that extra cholesterol. Adipose tissue, we have an increase in that anabolic pathway called lipogenesis, and that supports those maternal fat stores, like in the breasts, in the hips, obviously in the stomach area, anywhere extra fat is gained. In your proliferating nutrient targets, we have a huge increase in the amount of red blood cells being produced, as I've mentioned 5 times now. Increased erythropoiesis, that's the name of that anabolic pathway, and that requires 2.7 milligrams of iron per day. We also see a huge proliferation in reproductive tissues, which is by classification the uterus, the placenta, and the fetus. And those tissues are depositing 8 to 16 grams of protein, just depending on the day. And that occurs during the second phases of the pregnancy in trimesters 2 and 3. Whereas the expansion of blood volume and hemoglobin expansion happens in the first 2 trimesters. During the 3rd trimester, we do see some catabolic changes. Despite being in an overall anabolic phase, we do see some interesting happens with maternal cells. huge increase in insulin sensitivity, huge increase in hormone sensitive lipase, which is a hormone in the fat cell that breaks fats down to send them out into the blood so they can be used somewhere else. And also an increase in lipolysis, which is, that was a lot, but the pathway I just explained, the hormone that breaks down triglycerides into fatty acids to send them out into the bloodstream to be used somewhere else. Where do you think that somewhere else is? Yes, it would be at those fetal tissues. In the liver, we see a huge increase in gluconeogenesis, which is where the body is taking other carbon skeletons from fat and amino acids and turning them into glucose. And we're also seeing an increase in ketogenesis, which is the production of ketones from those amino acids. So in component 4, we're going to talk about the functions of these nutrients in supporting pregnancy and lactation. And we've already talked a little bit about those functions to support maternal growth and support the growth of the baby. But here we're going to look at it in our typical 3 categories: nutrient structures, nutrient operations, and of course those protective nutrient functions. Nutrient structures for reproduction. Well, first of all, hemoglobin. That is we've mentioned before, but hemoglobin is expanding. Mom's blood volume is, increasing by 30%, and hemoglobin is 35% iron. So most of that extra dietary iron is deposited into hemoglobin. When it comes to tissue nutrient structures, during the pregnancy phase, maternal and fetal gains total around 25 pounds. That's the median. And of that, about 20 is a tissue accretion, which includes these right here: breast tissues, blood, the uterus, the placenta, the fat stores, and about 5 pounds are retained water. So these are extra body fluids, which includes amniotic fluid. And this also, of course, is integrated into the additional 4 to 5 pounds of blood. When we look at the baby, this is the average weight of a newborn. And if you look up here, it shows the percent body weight of newborns. And very interestingly, they are much higher in water than we are, than adults are. I guess I should clarify. Adults are typically, in the high 60s, mid to high 60s, and babies are born with lots of water. And look how little they have of fat. So the average, adult, again, is anywhere from 15 to 25, maybe 30% fat, where they're down here at 13%. And 15% is, by the way, pretty lean. And then in the minerals, the newborn weight is about 3% minerals, which is that's a little higher than for the adults, which is around 2%. And of that, these are the mineral accretion rates per day. So you can see that these bone minerals, phosphorus, calcium, and magnesium, are needed in really steady amounts. So nutrients also supply the body that extra energy it needs. And just like we mentioned in component 1 about those additional energy needs, the reason or how they came up with these estimates of 350 to 450, which is the RDA is 450, how they came up with those values is looking at the amount of energy that it was expended per gram of deposited tissue. And that comes out an estimate, again, median based on studies, average size and weight pregnant women, about 180 calories per day. There's also, and this is just dependent on size and weight, so I didn't want to put as an estimate out, but basal increases like the thermic effect of activity and the heart and the lungs, and just to basically work your basal metabolism takes more too. Again, like we mentioned in component 1, in that 3rd trimester, the baby's also, or the fetus is also expending energy, approximately 170 calories per day. So all of those extra nutrients we consume, those are where they're going. For lactation, very straightforward. All of them are going into the milk, and some of them go into the cost of milk production. It is a pretty expensive anabolic pathway to produce milk. So what are the functions of stored nutrients during the pregnancy and lactation phases? Well, during the pregnancy, anywhere from about 6 to 8 pounds of fat are stored. And the function of that is to satisfy the fetus glucose. So if you remember, lots more gluconeogenesis. So that extra stored fat is able to be converted to glucose to supply the baby its energy it needs while mom isn't eating, while sleeping and working and doing things while fasting. During the lactation phase, that stored nutrient energy is estimated to provide about 200 calories each day into breast milk. So what that means is, of course, you're consuming nutrients that are going into breast milk production daily also, but that stored nutrient energy after or postpartum also supplies an estimated 200 calories in that milk that's produced. So now we're looking at the nutrient operations or the functions of these nutrients on a very micro level, like the vitamins and minerals. First one and the most critical is folate. And we've mentioned folate about how the needs go up, but the reason we need more folate is it's a coenzyme, like we talked about in lesson 5 with vitamins. Folate is a vitamin coenzyme that activates this enzyme called methionine synthase. And I know this is technical, but this is how to understand why folate is important in early pregnancy. Methionine synthase is an enzyme that folate completes, and this enzyme is needed to convert homocysteine into methionine. And long story short, methionine is a critical amino acid that we need to activate cell differentiation and protein synthesis. So protein synthesis reactions are critical early in pregnancy to close that neural tube. So nutrients, in some cases, the things that we consume in our diets, can also provide us defense against being nauseous. And this is called antiemetics or anti-nauseous things. They promote gastric tone and motility. Several compounds have been studied, including ginger. Also, it's recommended to have small, low-fat meals, drinks containing glucose, salt, and potassium, and supplemental B1 and pyridoxine. And you can also talk with your OBGYN more if you're having severe morning sickness. Now we're going to talk about the status measures during pregnancy. First of all, in the case of excesses, there can be poor outcomes, especially in the case of added calories and weight gain and sugars. It can create conditions like gestational diabetes. Extra salt can also contribute to high blood pressure, which again, the blood volume's increasing, so there is already a pressure issues. So making sure to, monitor salt is a good idea as well. Nutrients that significantly compromise. So if these nutrients are insufficient in the diet, several vitamins and minerals listed here, it can compromise pregnancy outcomes. And we'll look at what those are in a moment, but things like early pregnancy or early delivery or short-term pregnancy, low birth weight, and things of that nature. Now, one of the things that we do to look at nutrition status during reproduction is look at maternal weight gain. So usually the median values is that it's about 1 to 2 pounds per week of gained weight. One other anthropometric measure that can be used to red flag an OBGYN is, excess weight gain. And these are just some standards that you might see in a clinical practice to evaluate the rate of gain, because you don't want to gain too fast. But everyone is different. I will admit, I gained a lot of weight very fast every single time. Also during pregnancy, another anthropometric measure that's common is uterine dimensions, looking for how big the placenta is and the size and the weight, and they can estimate that by measuring the space. Another measure is, of course, looking at the fetus and newborn size, and sometimes in the case of insufficient intake of these nutrients, calories, folate, B12, iron, and magnesium, you can see instances of low birth weight or small for gestational age, which are defined down here. Biochemical measures, as I mentioned, sometimes excess nutrient imbalances cause hyperglycemia, where blood sugar is high during the pregnancy. And like we've mentioned, there are lots of metabolic changes, and so sometimes there are metabolic abnormalities that occur during pregnancy. Another important measure is in the urine is proteinuria, looking for proteins, because it can give an indication or a screening indicator for preeclampsia. So that's another important biochemical measure during pregnancy. There's also clinical measures where you would tell your nurse or your OBGYN things like your perceptible feelings, like, oh, I'm nauseous, or I'm tired, or I'm hungry and thirsty. These are common signs, and sometimes they can be related to poor nutrition. Some of the appearance changes that could be detected in a clinical setting might include maternal swelling, like in the legs and feet, looking at edema, and again, could be a sign of preeclampsia, and newborn observation, which you've maybe heard of these before, but at birth, a newborn is given an APGAR score. And although sometimes, these aren't related at all, they sometimes are related to nutrition. So insufficient nutrient intake can also cause functional declines. So in the gastrointestinal system, dehydration and insufficient fiber can cause or, contribute to the tendency to have constipation, which is trouble expelling feces, and hemorrhoids because of the extra pressure that the baby puts on the intestines. In the endothelial level, like we mentioned, that blood volume, blood pressure increases. If pregnant woman has more than 2 occasions with a hypertension or levels of more than 140 over 90 millimeters of mercury, then they have preeclampsia. And if they develop eclampsia, it's a very, very dangerous and potentially fatal blood pressure response to pregnancy. And they have to be very closely monitored and sometimes even on bed rest and medication. One of the most devastating functional declines during pregnancy is the pregnancy itself, meaning that the body isn't able to sustain pregnancy as long as it should. And so instead of a 40-week period, there are preterm labor. And these nutrients have all been associated when they're insufficient or low, very low levels in the diet, especially iron. It does contribute to preterm labor, whether moderately preterm or very preterm. And many babies, most babies, especially with modern health care and, hospital systems, lots and lots of preterm babies are perfectly healthy in every way, but it can cause some health problems, heart conditions and lung conditions and other things that just the baby didn't get time to quite develop those organ systems. Most devastatingly, in the functional decline, the area of pregnancy is the fetal outcomes. So again, within the case of folate deficiency, there are neural tube defects, and these include spina bifida and celepathy. When iodine is deficient in the diet, the fetus can be born with congenital hyperthyroidism, or sometimes in clinical settings called cretinism. And like this little cute guy right here, bless his heart. And also cleft lip, which, oh my God, that's such a cute baby too, where the lip clips up to the bottom of the nose. And this is also related to iodine deficiency during pregnancy. So, this is the last slide. And to wrap that up, nutrition for pregnancy is very important. So thank you for listening to this very long lecture, but hopefully you were able to tie together some of the lessons from part 2 on the nutrients to how it applies to this wonderful reproductive phase of life. Thanks for listening.